Hi, I'm Vineet Malik, a grad student in the computer science department at Purdue. I will present my project, a peer-to-peer real-time video chat application using WebRTC. In this project, I have implemented the application using HTML, CSS, JavaScript, and Firebase as the signaling server. It is hosted on the cloud. So it is hosted on Netlify. This is the URL p2p-connect.netlify.app. So I'll just start with a quick demo. I'll create two windows. Uh, to start, the user will first have to activate his webcam. Once the user activates his webcam, there are two options, either create a call or join existing call. So let's create a call. This will generate a call ID. It will be required by the other user to join this call. So this user will have to first activate his webcam. Now click on join existing call, enter the call ID, and click on join again. So as you can see, the call has started. There is a chat window. Sorry for the echo. So I'm sending a message. So this message is received. I also showed the real-time connection statistic. So I'll stop the call uh, to stop the echo. So yeah, so I stopped the call to stop the echo. So this is the current resolution, frame rate, jitter, and incoming bitrate. I also show a lot of the last 30 seconds of frame rate, bitrate, and jitter. So frame rate is represented as a line graph, bitrate as a bar graph, and jitter as a radar graph. This is for the last 30 seconds. Now let's move on to the implementation. So I will not be going over the HTML and CSS. That just describes the placement and design of the DOM elements. The core of the application is in the main.js file. So here I utilize the Firebase as a signaling server for the WebRTC calls. Firebase facilitates the exchange of signaling data between peers. Uh, so let's dive deeper into the crucial component of our application, how we use Firebase as a signaling server for WebRTC calls. So first, let's understand what signaling means in the context of WebRTC. Signaling is the process of coordinating communication between peers in a WebRTC application. It involves exchanging information like session descriptions and ICE candidates, which are necessary to establish a peer-to-peer connection. So why did we choose Firebase for this task? Firebase offers a real-time database, which is perfect for the quick exchange of signaling data. So let me show you how it's set up in our application. So here we initialize the Firebase with our project's specific config. The setup enables the application to connect to the Firebase real-time data store. So let's move on to the create call function. So the function is the starting point for a new video call. So when a user initiates a call, we create a new document uh, in the Firebase database under the calls collection. This document will store all the signaling data related to this call. Uh, an important part of this signaling is the exchange of ICE candidates. These candidates represent potential connectivity pathways between peers. Uh, Whenever a application finds a new ICE candidate, we add it to the Firebase database under the offer candidates collection. This allows the other peer find and use these candidates to establish a connection. The next step is setting the offer. We create an offer and set it as the local description of our peer connection. This offer is then written to a call document in Firebase. The remote peer will read this offer and create an answer and write it back to the same document. Let's move on to the answer call function. So for a peer to join an existing call, uh, they use the call ID to fetch the call document from the Firebase. The peer then retrieves the offer, creates an answer. Uh, simul- Simultaneously, the IC candidates from both the peers are exchanged through their respective collections in the database. Uh, Now let's quickly discuss the chat functionality. So we set up the data channel. This is independent of the video stream. Uh, and whenever uh, this is for the listener for the channel event. So whenever we receive any message, this method will be called and it will update the HTML chat window. Uh, and the send message button basically just sends the message into the data channel. So an interesting aspect of this project is the real-time statistics reporting. So let's discuss that. So this method reports the statistics, real-time statistics, and it is called every 2 seconds. So uh, as you can see, we fetched the report, the stats report from the RTC connection, and uh, for the incoming video, we capture the frame rate, jitter, resolution, and the byte received. And for the outgoing video, we capture the byte sent. This will be used in our new design of adjusting the bitrate. So over here, we just compute the bitrate, uh, which is bytes received minus the previous amount of bytes received uh, divided by the timestamp. And uh, so this is just updating the charts. Uh, these are arrays of frame rates, bit rates, jitters, which are used in generating the plots. These arrays have a maximum window of 15, and since it is called at an interval of every 2 seconds, so it captures the real-time analytics of a 30-second window. So finally, let's moving on to the new design of adjusting bitrate on the basis of bytes sent. So what we do is we compute the bytes difference, which is the amount number of bytes sent uh, minus the number of bytes sent the last time. So this if this byte difference is positive, that is the number of bytes sent increased. And if it increases by more than a threshold value, which is kept as 10 KB, uh, then we increase the max bitrate by an increment of 100 KB. Uh, Uh, if it falls more than the threshold value, then we apply a severe penalty by making it half. So it is kind of similar to the TCP congestion control. Uh, and lastly, we just update the current bitrate value, uh, setting the max bitrate equal to the value which was computed in this method. Uh, so let's give a quick demo of this adjust bitrate method. So initially the bitrate is increasing linearly. Uh, I also conducted sorry for the echo. So as you can see here, the bitrate became almost half, and then it started increasing linearly again. So I also conducted some experiments via calls locally versus international calls. Uh, I also conducted experiments by changing the devices PC versus mobile and on different network types, mobile network versus Wi-Fi. So the results I will be provided in the report. I'll also put the report on the GitHub soon. Uh, uh, so all this code is present on the GitHub. You can go to GitHub from the website itself. So over here is a link, and this is the GitHub. And thank you for attending the presentation.